We now talk about the event points in this algorithm. So here we can identify three types of event points. So the first two types of event points are kind of intuitive and obvious. The third one could be obvious, but maybe for some people it could be a bit unintuitive. So the most obvious event point is that when the sweep line reaches the top end point or top vertex of a segment, then we know that we have to add that segment to the picture. So that's what we've seen so far. Similarly, if the sweep line passes the bottom endpoint of a segment, then that segment is out of the picture, so we could just ignore it. So those two are the two obvious event points. There is also another event point, and that is when the sweep line reaches an intersection point, we also need to do something, but to sort of to observe that, we need to know a little bit more about the sweep line algorithm. But have this in mind. And overall, throughout this entire sweep line algorithm, we maintain a particular invariant that I'm going to talk about here. The invariant that we maintain here is that at any given point in time, we want to have discovered all the intersection points, or of all the line segments that are currently in play, in some sense. So I will make the invariant a bit more precise later on. But the idea here is that above the sweep line, I should know what is going on. Below the sweep line, anything could happen. Like if I move slightly below, I could discover tons of new line segments. But above the sweep line, I have discovered all the segments that are there. There is nothing new, no new segment above. And therefore, I kind of should know all the intersections above the sweep line. Okay, so that's the basic invariant that we're maintaining, and that's why we need these event points. And to implement the sweep line algorithm, we need to have two types of data structures. One data structure that is essentially common or essential for all of the sweep line algorithms is a data structure that can store the list of the event points. And this is almost always a priority queue. So the priority queue stores all possible event points. You just add it to the queue. You allow using some insertion operation of the priority queue. And after you add it to the priority queue will tell you what is the next event. And this is why we need priority. So for example, let's go back to this algorithm. Let's go back to the picture. Before this algorithm starts, you populate the priority queue with all the event points. This includes the start events of a segment and the end events of a segment, right? So you have SI and say EI. And you add all of them to the event. And the priority here is the Y coordinate. So therefore, the event with the highest priority before any event has been found is the start of some segment. So some SJ will have the highest priority because it will have the highest Y coordinate. So the first priority to pull out from the priority queue will be the start of some segment. And at any given point in time, the sweep line will know what is the next event coming. By looking at the priority queue, the top of the priority queue will tell you what is the next event. So now in this picture, for example, this could be the next event. Okay? So by having all the event points added to the priority queue and having the priority to be the Y coordinate, we could easily implement this discrete jumping around idea. But that's not enough. To be able to run this algorithm, we also need another ingredient, and that is the status of the sweep line data structure. This is a data structure that stores the status of the sweep line, and what this means in this particular algorithm is that it stores the ordered list of segments as they intersect the sweep line. So for example, if your sweep line is, let's go back here, if your sweep line is like this will store that this is segment number 1, this is segment number 2, and this is segment number 3. So it will store them in that order. For example, using a convention that we store the order from left to right. But if the sweep line, for example, reaches, say, let me just do an example here. If a sweep line reaches here, then this would be segment number 1, this would be segment number 2, this would be 3, let's say this is 4, and this is 5. Okay. These numbering are not necessarily explicit, but what we need from this data structure is to be able to find the next and the previous, and to be able to do some searches. And I'm gonna talk about this structure later on. But so far, these are the two data structures we need. So those are the ingredients, and in the next video I'm going to talk about how we use them to solve this problem.